COM port or serial port. It is also called as COM port or serial port, which is a communication like a serial wire communication, which can be done between the microcontrollers or any peripheral devices. If you want to connect some modules like GSM module or GPS module or Bluetooth module or Wi-Fi module, you could use this UART for communication. So RS-232, it is also called as RS-232 and RS-485. Like if you want to extend the length, like usually the UART communication length will be around 3 meters. If you want to extend more than 3 meters, like 10 meters, if you want to extend that to up to 10 meters, then you can go for RS-485 communication. Okay. There are also other type of communication like SPA and I2C, which will be covering up later, serial peripheral interface and the inter-integrated circuits. But UART is the major serial communication, which is widely used on embedded system design. Okay, so you can communicate microcontroller with the computer or an FPGA or any device which supports UART. The only disadvantage of UART is both the device has to be synchronized in order to communicate. Okay, so it should have both the device should be on the same baud rate. Okay, baud rate is bits transmitted per second. So it should transmit on the same baud rate. The receiving end also should receive on the same baud rate. Okay, only if the baud rate is synchronized, then you can transmit or receive the data. And it's very common and it's very simple. Usually it has only 3 wires. One is the transmitting and the other is the receiving, the other is the ground. Okay. By using these 3 wires, they used to connect the devices. It is generally it is not used to connect multiple devices. It is used only for two-way communication, like on 2 devices. When you try to connect multiple devices on the same bus, then you may got bus contention issue on UART. Okay, when multiple devices try to drive the bus at the same time. So UART, if you want to communicate only 2 devices, then UART is the best communication platform. Okay. So there are 2 types of UART communication. One is the asynchronous, the other is the synchronous. Asynchronous does not require a clock signal. Okay, so you can transfer only byte data on asynchronous, whereas synchronous communication, it uses the clock signal, whereas you could transfer a bulk data in the framed structure at a time. Okay, so asynchronous does not require a clock. Whereas synchronous, it requires a clock, it can send more data. Asynchronous can only send less number of data since it's transferring the data without clock. Okay. So usually there's that if you look at the timing diagram of the UART, you could see the start bit first, which is 0. Okay, and the stop bit will have 2 ones. So whenever the pin is high. So usually the pin is high when the data is not transmitted. When the pin starts low, it means the data is going to transmit at the start bit. After that, you'll be sending the frame totally of 8 bits. After 8 bits, you'll be giving a parity bit, 1 bit or 0 bit, or any other CRC bits, and finally the stop bits. Okay. So this is the frame structure of UART, timing diagram for UART. So usually the transmitter will be connected to the receiver part of the other end. For example, if you're going to connect FPGA and the PC or a microcontroller and a PC, you'll be having transmitting pin and the receiving pin on the UART and ground pin. Okay, so the ground pin and both the ground pin has to be connected. The transmitting pin of the FPGA will be connected to the receiving pin of the PC. Okay, the transmitting pin of the PC will be connected to the receiving pin of the FPGA. So this type of communication is called cross communication. So usually the UART communication will be done in a cross communication. Okay. It supports simplex communication, one-way communication, and duplex, half duplex, and full duplex communication. Okay, UART supports both. UART supports both simplex, half duplex, and full duplex. Okay. So these are the UART parameters. like baud rate. There are multiple devices can transmit on multiple baud rates based on the clock of the processor, like 9600 bits per second and 19,200 bits per second and 1,15,200 bits per second. So the number of data bits may be 7 and 8, but widely used is 8 bits. Okay. So parity bit is 1, on or off. That's a parity bit, and stop bit is optional. 0, 1 and 2. Stop bit is 0, 1 and 2. Maybe sometimes stop bits may have 0. Sometimes it may have 1 bit. Sometimes it may have 2 bits. Okay. Flow control, it's optional. It's none on hardware. So these are the UART parameters. So you have to set when you synchronize both devices, okay, to transfer data. So let's go for the implementation of UART on STM32F411. Okay. So the applications of UART, like before we go, the applications of UART, like any serial communication, any communication, if you want to do with a microcontroller, you can use UART. Okay. There are two types of UART. One is the hardware UART, where you will have the registers and everything on the microcontroller. Like you will have the dedicated pins for that in hardware UART. The software UART is you can configure any GPIO pin as a serial port by using the software. Okay, so that is called software serial port. So there are two ways you can use it. In some microcontrollers you may have one serial port. In that case, you may use a software serial port for additional UART. Okay, so you can either configure hardware UART or software UART. Software UART is the UART created by the software. It is not on the device. Usually, the GPIO pins will have multiple, will be multiplexed, like will have multiple functions. Will have an alternate functions. The GPIO, general purpose input output signal, GPIO pins will have the alternate functions, which has the SPI, I2C and UART. Okay, so you have to find out the GPIO with alternate functions. Sometimes the GPIO will be dedicated, so it's only used for input and output. Sometimes it may have an alternate functions. So if you check out the block diagram, of STM32F411 series, this is the block diagram which I have taken from the data sheet. I'll show you the data sheet. Just give me a moment. Okay, so this is the data sheet. Let me open it again. Okay, if you check for the functional overview, like you will get a block diagram on page number 'm. Okay, so this is the block diagram. Let me show this. This is on page number. There's no page number here. Okay, page number it's 14. Okay, 15. So this is the block diagram of STM32F411. Okay, you have the Cortex M4 architecture here. Okay, the ALU unit, the floating point unit here, which is connected to EHB bus matrix, which is connected to the EHB1 bus. Okay, so in today's class, like we are going to use USART2. There are also other USART like USART1 and USART6. I have chosen USART2 because we are using the Nucleo board which has the onboard USB to UART converter, okay, which is used for the which is used for debugging, which is used for programming. The same thing can be used for. It also has the RS-232 like USB serial port, USB converter, serial converter. So USART2 is connected to that converter. Okay. So if you use USART 1 or USART 6, then you need an FT232 USB to serial converter. So in order to test the program, like I'm going to use USART 2. Okay. So if you find out this block, if you go through the block diagram, you have to find out what bus it has been connected. Like it is connected to APB1. Okay. Advanced peripheral bus. Okay, which is connected. USART2 is connected to advanced peripheral bus. So you have to enable the clock for this bus. Using this USART2 peripheral. Okay, but when you check the pin details of USART2, so it will be multiplexed. Okay, you have to find out multiplexed. It is connected to GPIO port A. Okay, if you check USART, like let me check USART2. Okay, so this is the pin definitions. Okay, this is the STM32F411 pin definitions. This LQFP is a package. So USART2 like CTS, RTS, VDTX. Okay, USART2_TX and USART2_RX. So it is connected to PA2 and PA3. Okay, it is connected to PA2. P stands for port and A stands for port A. And 2 is the second pin, okay, and 3 is the third pin. A stands for port A, port B, or port C. If it is PD, then it is port D. Okay, okay. So it is port GPIO port A. So it also has other alternate functions. I2S timer. The same pin is also used for other alternate functions. This is the alternate functions. Okay. So you have to configure the mode register of this port A, GPIO port A, to the alternate functions. Okay. First, you have to two things you need to remember. Okay. Two things you need to remember. You just go for the block diagram. It is connected to USART2 is connected to the GPIO port A. Okay. PA2 and like it is connected to port. Okay. PA2 and PA4. Let me check one more time. It's PA2. It's PA2 and PA3. Okay, it's PA2 and PA3. So you have to. So PA2 GPIO port A is connected to AHB. Okay, this AHB advanced high peripheral bus. So AHB like. So if you check out this AHB AP, to which bus it is connected, okay? AHB1. It is connected to AHB1. So you have to enable the clock for AHB1 as well as the APB1. Okay, you have to enable both. So once you identify the USART and the GPIO and the bus, so from this block diagram, you have to identify three things. USART2 is connected to which bus? Okay, APB1. Okay, if you are going to use USART1, then you have to use APB2. Okay, so every APB1 has a unique base address. APB2 has a unique base address. Okay, so you have to find out the base address. Either you just open the software and you download an empty code, and you could check out these special function registers on the emulator. That it's one way. The other way is to use the data sheet. Okay, so I suggest you to use the software version because it's very easier. Else you need to correctly add the offset value to get the right value of the register. So in this block diagram, you have to find out which USART is this. You have to choose a USART. Once you choose a USART, you have to find out which bus it has been connected and what is the GPIO pin, associated GPIO pin for that USART, and this GPIO, which bus it has been connected, APB1. So you have to enable clock for this bus and for this bus, okay, in order to communicate. And then like GPIO, you have to set the alternate functions, okay. You have to configure the mode, alternate functions of the mode registers, and finally, like, you have to get the value. Let us check for the program, okay. Once you find the associated GPIO, and you have to check for the functional mapping, okay. So functional mapping, like you will find out the pins here. In this functional mapping, you will find out the pins like PA2 is connected to USART2 and PA3 is connected to USART2. And on the top, you have AF07. Okay, so this is the value like which is used for the alternate functional mapping. I'll show you on the program. Okay, so these are the steps for writing the program for your transmit. Okay, so this code is a lengthy version, so we will complete part 1 today, and tomorrow class will be completing the part 2. The rest of the version will be completing the part 2. Okay, so let us write the driver today, and tomorrow like we will try to write the applications. So steps for your transfer. First thing is you have to enable the clock access to the GPIO, because the user 2 is connected to GPIO. It's an alternate function, so you have to enable the clock access for the GPIO, and you have to set the port A to PA2 like mode register to alternate function mode. Okay, and like alternate function type you have to mode, and function type you have to configure. Then configure the UART module, okay. Then enable the clock access to the USART module, and configure the baud rate. You have to configure the baud rate based on the system clock, okay, based on the clock frequency which used, and configure the UART transfer direction and enable the UART module. So these are the steps. I'll go one by one. I'll start the program from scratch. I'll go one by one. I will open STM32 cube IDE. Okay. Let me create a program called day 23 demo. So I just copy the path, and I'll just paste it here. Click launch. How to create STM32 project. Okay. Go for file, new STM32 project. Hit board selector and choose the board. Click next. So I just give us name as UART. Click empty. Click finish. Okay. So once you create the project, like you add the source file. Like source file is already there. Okay. Let me check the source file. Okay. This is a file. So I'll increase the font size. So I'll go for Windows, go for preferences, general, click general, appearance, colors and fonts, C++, editor. Okay. I choose a font size as 18, click, okay, apply and close. Okay. So first thing is like, let me compile this one, right click, build the project. Let me connect my board and okay. So I have connected the board. Right click and give us debug as STM32. This is just for just for the SFRs, to view the SFRs, so that you could take the memory map from the directly from the SFRs. Else you have to go through the data sheets. I'll also show you how to take the value from the data sheets. Okay. You just go for window, click show view and click SFRs. So you'll get this SFRs. Okay. So let's copy this command. Okay, let's copy this command and let me go step by step. Okay, so the first thing is to enable clock access to GPIO. Okay, so you have to enable the clock access to GPIO. So to enable the clock access, like you have to go for the RCC. Okay, first you need to configure this RCC. So to configure this RCC, okay, you need to create a pointer variable. Let me create a pointer variable. So uint 32 underscore t. Okay, it's port AH B1 ENR. Okay, so this is the AHB1 ENR. This is the you have to enable GPIO AEN here. Okay, you have to enable this one. So you have to typecast this. Zero X 40002 and 3830. Okay, 3830. 4002 3830. So this is the value. So you just copy this. You need to enable the APP1. Okay, APP1. So this is the bus which is connected to the USART2. See, you have USART2 enabled here. So I'm going to use the same name, APP1 ENR. Okay, APP1 ENR, and this value is 3840. 4002 3840. Okay, 3840. to 3840. Okay, so next you need to configure the mode registers. Okay, RCC is okay. You just go for GPIO because USART2 is on GPIO. You have to configure the mode R, and you need to configure the alternate function. AFR stands for alternate function. Okay, so just copy this. I just name it as GPIO underscore mode R. Okay, the value is 044. Okay, the next is GPIO AFRL. AFRL. Okay, and you have to configure this as 0020. Okay, 0020. Say this one. Okay, So next you need to configure Windows. Let me check for the support. We have configured the GPIO. We have to configure the USART. USART 2 registers. USART 2. In USART 2, like we have to configure this data register, okay, SR and BRR, like baud rate. So just copy this. So I will rename this as USART 2. USART 2. Okay. USART 2. We'll start with the SR. So SR is 440. Okay, 4400. SR is 4400. I copy this, paste it here, and this is DR. Okay, DR is 4404. Okay, copy this, paste it, and this is BRR. Okay, BRR. It is 4408. And this is CR1. Okay, CR1 is 440C. This is 440C. Okay, so you have to first, you need to configure this. Let me check. Right click and build the project. There's no error now. So we have to enable the clock access now. So let me define of GPIO. Okay, GPIO A enable. This one, this is unsigned 0. Okay, this is to enable GPIO, and this is to enable UART 2. UART 2. This is 17. Okay, this is 17. 17. Let me declare this frequency also, hash define of system frequency, the clock frequency, system frequency. Okay, is 16 megahertz. Okay, 16 megahertz. Okay, so APP1 clock, hash define APP1 clock. Okay, APP1 clock, this. Okay, so let's define the baud rate, hash define UART underscore baud rate is 1,15,200. Okay, okay, so first we need to enable this GPIO enable. I'll show you, like so let's create a function called UART to turn init. Okay, UART to initialization. So I just create a function called initialization void of UART2 underscore tx underscore init. Okay, copy this and declare this here. Okay, right click and build the project. this is the initialization code. Let me initialize this code here. Okay. So the first thing is to enable the clock access to GPIO. So this is the GPIO. Okay. Mode register. So before that, you have to enable this port AHB1 ENR. So just copy this. Just copy. And enable this one, GPIO AN. Okay, enable this one. So let me check whether it is enabled or not. Right click, build the project. It just debug. Okay, debug a STM32 Cortex application. Switch for the debug perspective. Just go for step-by-step execution. Okay. So if you check now, like I have, the code has been completed. Like if you check the RCC register AHB1 ENR, okay, AHB1 ENR. This is the register AHB1 ENR. Okay. AHB1 ENR. This is the one. Okay, this is the one. If you check on the item side, if you check like GPIO AEN, it's enabled. Okay, it's enabled. So we have enabled the clock access to the GPIO A. Now we have to set this mode register. Okay, GPIO A mode register. Double click. You have to set the mode register as alternate functions. I'll show you in the data sheet. Just go for the registers. Okay, so in this mode register, here is the function 10. You have to store alternate function mode. Okay. It is on port 2 and port 3. So you have to set 10 here. Okay, 1010. So 1010. So to set this 1010 here, this is 5th pin. Okay, so transmitting. So we are going to set transmitting. So in order to set this, just come for the program, switch to the C++ perspective. There's an icon here to switch it back. Okay. Okay. So copy this mode R register. First, you just clear that one. Okay, negation of 1U is for unsigned. Okay. Copy this. Okay. So we have set the register now. We will check for the next one like this. Here set PA2 mode. Okay, this is PA2 mode. This is the set PA2 mode to alternate function mode, and this is the enabled clock access to the GPIO. So we have kind of two things. Like one, we have enabled the clock access. The other is we have set the PA2 mode of alternate function mode. Okay. Now we need to set the function type, set the alternate function type. It is on AF or on. Okay, you have to set this on AF or on. Okay, so copy this. Okay, so you have to set eight. Okay, how to set and this is negation. I'll show you in the data sheet. So if you go for the alternate function register, so you just go for GPIO alternate function register. Function load, this is the one. Okay, GPIO alternate function load register. Load register means if the port is between 0 to 7, you have to use this. So here, like this is 0, 1, 2. At this place, you have to set AF7. AF7 is 0. This is 0, 1, 1, 1. Okay, so the rest of the place you have to set 0. So 0, 1, 1, 1. So this pin is 8. Okay, it starts from 0, 1, 2, 3, 4, 5, 6, 7, and this position is 8. So we are shifting for 8. Okay, the next is 9, and the next is 10. Okay, and 11. So this is 0. So we have set that, and it is not or, it should be and. If you want to clear it, it's and. Okay, if you want to set, you use or. Okay, so we have set the PA2 alternate function register. Okay, so the next is to configure the APP1. Okay, you have to configure the UART module. You have to configure the UART module. So that is the APP1, this one, APP1 ENR. So APP1 ENR, you just go for APP1 ENR on the RCC register. Okay, USART2, you have to enable this USART2. Sorry, this one. USART2. Okay, it is 17. It is 17. Okay, it is 17 bit. So I just copy this one. Okay, so this is 17. Okay, so I just copy this. Or let's see what. Okay, we have set that one. So the next is to we have to load the baud rate. So for that we need to write a function baud rate, and then we have to set the like CR1 register. Let us create a function for baud rate. Okay, so let us create a function for baud rates for static. It should have a return value of unit 16t. Okay, so I just renamed the function as compute UART underscore baud rate calculation. Okay, so function parameter input parameters like peripheral clock is the input. Okay, peripheral clock. Peripheral clock is the input, and uint 32 underscore t baud rate is also an input. Okay, so it should return. You have to calculate the baud rate formula, like it should return okay, this peripheral clock plus the baud rate. Okay, baud rate divided by 2, it's unsigned, telling the compiler it's unsigned. Okay, divided by the baud rate. Okay, divided by baud rate. It should return this value. Let's check. And so we have to load the baud rate register. So the baud rate register is B or R. Okay, USART 2. This is the baud rate register. You have to store the baud rate register here. Equals compute UART underscore BD. Okay, you have to pass this APP1 clock. The bus clock. Okay, the other is the baud rate, UART baud rate. Okay, copy this and you paste it here for prototype definition. Okay, so save the program. So right click and build the project. So it has 5 errors. Let me check this GPIO. Right click, build the project. Okay, so project build has been successful. So the rest of the part we will continue tomorrow. So as of now, I repeat what we have done. So we have configured the clock access to the GPIO, and we have set the alternate function mode, and we have set the alternate function type. Okay, and we have also configured the UART module on APP1 ENR, like advanced peripheral bus. Okay, this is advanced high performance bus. The top is advanced high performance bus, which is to enable the GPIO. So only the GPIO pin A has the multiplexer. Okay, whereas the peripheral USART is connected to the APP advanced peripheral bus. So you have to enable both the clock access to this one. Okay, you have to enable and compute UART baud rate. Okay, you have to store that on the baud rate register. So the remaining rest, like to configure the transfer direction, to enable clock access, to configure baud rate, this we have done. Okay, configure transfer direction and enable UART module, we will complete tomorrow in tomorrow's class, and we will also see how to transmit UART and how to receive UART. Okay. With this, I close this lecture. See you on the next session tomorrow. Until then, bye-bye. Take care.